All right, everybody, welcome to the video for lesson number 1 in chapter number 4 on trigonometry. So for the first question here, we needed to remember the sum of the sides of a right triangle, a special right triangle, the 30, 60, 90 triangle. So first thing I'm going to do here is, actually, I'm just going to move this down for a second. So I could actually draw the 30, 60, 90 triangle for us. So if I have a 30, 60, 90 triangle, I know the ratio of the sides are 1, 2, and square roots of 3. So when I see the cosine of 30, I know I'm talking about the square root of 3 over 2 because it's the opposite over the hypotenuse. Knowing the triangle helps. The tangent of 60, well, tangent is opposite over adjacent, so that would become the square root of 3. Knowing some basic algebra allows us to cancel those 2's. So now I have the square root of 3 minus the square root of 3, which is 0. The next one, the sine of 30, sine is opposite over hypotenuse, so that would be 1/2. The cosine of 30 is the square root of 3 over 2, both of which are squared. If I square 1/2, I get 1/4. If you're not sure why, just square 1 and square 2, and you get 1 over 4. Same thing happens when I square the square root of 3 over 2. The square of the square root of 3 is 3, and 2 squared is 4. 1/4 plus 3/4, well, that's just the number 1. So knowing this triangle is important. Let's take a look at number 2. Number 2 gave us a triangle with two angles labeled alpha and beta. Because this is a 90-degree angle, I know that the segment of the angle of alpha plus the angle of beta is equal to 90 degrees, or they're complements of each other. So if I find the sine, cosine, and tangent of one of them, I can just find the other ones by knowing the relationships we talked about in class. So the sine of alpha, well, if we're talking about alpha, we're talking about this angle. So this is opposite, this is adjacent, and the side that we don't know is the hypotenuse. 6 and 4 are not part of a Pythagorean triple, so I would probably go through and do 4 squared plus 6 squared equals c squared, or 16 plus 36 equals c squared, or 52 equals c squared, or the square root of 52 equals c. Well, the square root of 52 can be simplified. The square root of 52 breaks down to 4 and 13, or 2 square roots of 13. So I know this side is 2 square roots of 13. So the sine of A is 6 over 2 square roots of 13, which reduces to 3 over the square root of 13. And then if I rationalize, I wind up getting 3 square roots of 13 over 13. Well, if I know the sine of alpha, that should tell me the cosine of beta. So right away, I know this is going to be the square root of 13 over 3. Notice I'm taking the reciprocal of the unrationalized fraction because it's easier, right? If I take the reciprocal of the rationalized fraction, then I'm going to have to rationalize the rationalized fraction, which is just a lot of rationalizing. I know I just said rationalizing a lot, but you get the idea. All right. The cosine of alpha is going to become 4 over 2 square roots of 13, which reduces to 2 over the square root of 13, and rationalizes to 2 square roots of 13 over 13. Well, if I know that, I could just take the reciprocal of the unrationalized part, and I get the square root of 13 over 2. Tangent is the opposite over the adjacent, which reduces to 3 over 2. Tangent of beta, or the angle that makes the complement, is going to be the reciprocal, so 2/3. Again, I don't have to do any work to find that. If you want to, you can. It's just extra thinking. Let's look at 3. 3 tells us that we have a right triangle. It doesn't give us the picture, so I'm going to draw it. I'll put theta in there. It tells us cosine, which is the adjacent over the hypotenuse. So this is 4, this is 5. If you know your triples, you know the other side is 3. So if I want to find the sine of this angle, it's going to become 3 over 5. The tangent of this angle is going to become 3 over 4. Number 4 gives us these two triangles. It says, consider the two triangles and explain why the two angles are not congruent. Well, the sine of theta can be found, not the sine, duh. The tangent of theta can be found. That's 4 over 16. So the tangent of theta is equal to 1 over 4. This weird little symbol is mu. So I can say the tangent of mu is equal to 8 over 20, or the tangent of mu is equal to 2 over 5. Since these two expressions are not the same, I know these triangles are not similar. Therefore, if the triangles are not similar, the angles are not the same, right? So I could say triangle CAT is not similar to triangle DOG. The ratios are all messed up. And the last one, it says, consider a right triangle whose acute angles alpha and beta. Explain the relationship between alpha and beta. Then describe the relationship between the sine of alpha and the cosine of beta. This is essentially a sum of everything we talked about in class today. So if I have a right triangle with these two angles as acute, I know that the measurement of alpha plus beta must equal 90 degrees. Because if it's a right triangle, I know one angle is 90 degrees already, so the other two have to be 90 degrees. And if I have two angles that are complements to each other, the sine of one of them is equal to the cosine of the other. That's it. Hopefully this video helped you understand your homework, or at least got a chance to check your homework assignments. Hopefully you're not too intimidated by the size of the blue packet I gave you today, and we could kind of keep going and learning some of this stuff. All right. Memorize those triangles. They will help you, I promise, and good luck.